We're now moving on to extraneous variables. I'm first going to cover what an extraneous variable is, and then I'm going to cover how and why we need to control them. First of all, let's start with what is a variable. Okay, let's look at a normal variable. So a variable is something that is changing in an experiment and that we're measuring and seeing the effect of that change. Extraneous variables are variables that exist that we are not measuring and that we're not interested in seeing the change about. This might not make a lot of sense yet, but come back. Well, I'm going to go to the next slide, give an example, and we'll come back and you will hopefully see that it does. Okay, so Laura's carrying out a science experiment. She's seeing how long it takes for salt to dissolve in different temperatures of water. What are the variables that Laura is interested in? What is she measuring? So she's measuring time, how long it takes for salt to dissolve in different temperatures. So she's interested in the temperature of the water and the time that it takes. That is what she is measuring. Now, an extraneous variable is something that is going to affect these results, but we aren't measuring or we aren't interested in. So what else could affect the time that it takes for salt to dissolve? These could be various things. For example, the amount of salt added. Let's do this in a different colour. So the amount of salt added, that's going to have a huge impact. If she has loads of salt, it's not going to dissolve as quickly, is it? If she has a tiny bit of salt, it's going to dissolve quicker. So the amount of salt is really important. Another thing is important is she stirring or not? If she's stirring the salt and water solution, once again, it's going to dissolve quicker if it's been stirred. And also the volume of the water, a higher volume is going to mean it dissolves quicker. Okay. So all of these things are extraneous variables, and all of these things therefore need to be controlled. Why do they need to be controlled? They need to be controlled so we can be confident about the effect of the different temperatures of water on the time that it takes. So how could you control the extraneous variable? I've listed 3 in a GCSE. They may ask you to list 1 and state how you would control it. So amount of salt. If you'd written that, you would say use the same amount of salt, measure out the same amount of salt for each experiment, for each different temperature of water. Stirring or not, you may make a decision either to stir each time or to not stir each time and to stir at a constant speed. And volume of water, you would just say that you would make sure the volume of water was consistent, was the same between each sample. Okay, why is it important to control it? To show the true effect of the 2 variables that you are measuring, okay, which in this case is how the different temperatures of water affect the time that it takes for salt to dissolve. So back to this slide, the variable, the ones well, they're all variables, but extraneous variables in particular are variables we are not measuring and we're not interested in, okay? And I'm going to add a side note here. These need to be controlled. Okay, conditions must be exactly the same for both groups, other than the variable you are measuring. Right, so Laura's carrying out another science experiment. She sees how long it takes for salt to dissolve in water. That's the one we've just done. Let's go on to a different one. So Max is carrying out an experiment. He wants to investigate how many hours of revision students do affect the results of their next maths test. So have a pause, think about what your 2 variables are and what your extraneous variables could be. So your 2 variables are the hours of revision and the maths test result. Okay, they're the 2 things that we are interested in. Extraneous variables then. What else could affect someone's result, but we're not measuring? The amount of sleep someone's had. That could affect the result. If you're tired, you may perform less well. Your intelligence. Higher level of intelligence, you may perform better. Okay, so have a think about these are the extraneous variables, the things we are not measuring. One more, Ollie's carrying out an experiment. He wants to investigate how much water a plant has affects the height of the plant. What are your variables then? So the two variables are amount of water and the height of plant. Amount of water and the height of the plant. So what are the extraneous variables going to be? What are the other things that could affect the height of the plant? You could say amount of light and the temperature that the plant is in. Both of those would affect the height of the plant. Okay, right, we are on to the next section then. So this next section talks about control groups and how we can make sure our extraneous variables are being controlled. So a control group is sometimes called a comparison group. So I'll write that down, a comparison group. So it's used in an experiment to test the effectiveness as a treatment, the effectiveness of a treatment, to check that the experiment actually works. It's making sure that the treatment you are given is causing the experimental results and it isn't something outside the experiment causing it. Okay, and this is how it works though. So we randomly select two groups of people, and these are called the control group and the test group or experimental group. Test group, experimental group, and the control group. So just looking at these then, so the test group of people receive a particular treatment that we're meant to be giving. The control group, this group of people do not receive the treatment. Now the purpose of this is that we can be sure when we compare them the effect of the treatment on the test group. Okay, conditions are kept exactly the same for both groups other than the treatment is given here. Okay, compare the results of the two groups to see how effective the treatment is. So it's really important that all the conditions are kept the same apart from the treatment. So that's a control group. A matched pair test is like that, but in a little bit more detail. So two groups of people are used to test the effectiveness of a particular factor, but each individual in one group is paired with an individual in the second group who has everything in common with him or her except the factor being studied. So it's very similar to having a control group, a test group and a control group, but this time it's less random. You would make sure that someone has loads of similarities, or the factor, whatever you're measuring, has all the similarities to the other thing as much as within your control, other than the drug or whatever you're doing, the test, the treatment, whatever you're giving to the test group. Okay, now obviously, this kind of comes with its limitations. You're not ever going to have everything exactly the same, but as much as possible. And the whole idea of this is to try and control the extraneous variables. Okay, so if you were back to Max's experiment with the amount of revision someone did and their test score, you would make sure that these students were identically matched in intelligence. They'd had the same amount of sleep. They'd had the same food, to kind of fuel them. They'd had the same drinks. Absolutely the same as much as possible, other than the hours of revision would be different. Okay, student A might do more than student B, and then you could compare the effect of the revision. Okay, so that's a matched pair test.